So a chapter 4, it's actually a pretty short chapter. There's only a couple sections in it that we need to cover. So it's basically 4.3 and 4.4. So for 4.3, the first section focuses on something called the right angle theorem. What that right angle theorem says, that's theorem 23. It says that if two angles are both supplementary and congruent, then they're right angles. Which makes sense, because think, if you have two angles that add up to 180, but they have to be the same, then they have to be 90 degrees, which means they have to be right angles. So let me show you how this is used in a proof. So it says, given that AB is congruent to AC. So again, AC keeps getting cut off here. And we know that BD and CD are congruent. We want to prove that AD is an altitude. Okay. Well, if we think backwards now, in order for it to be an altitude, we need to have a right angle. In order for it to be a right angle, we need to know that AD is perpendicular to BC. So we copy our first line. These are two triangles that are together, so we can use the reflexive property here to say that AD is congruent to AD, which then allows us to say that the two triangles are congruent by side, side, side. Then by CPCTC, we know that this angle right here is congruent to this angle right here. Now, what I would also suggest, let's just add in our new lines from what we had been doing all along. So we have to say that angle BDC is a straight angle, and we're going to assume that. So that's actually line 5. And then we're going to say that angle BDC equals 180. And that's definition straight angle. So that's number 6. Because again, in order to say supplementary, the idea is that it has to be equal to 180. So you need to get that straight angle assume line in there. You need to get the 180 for the definition straight angle. And then at that point, this is 7, you can say that ADB is supplementary to ADC by definition of supplementary angles. So just make sure those two, we have to, when you're writing it out, 5 and 6 need to be included in there. Now, not only have we now, in line 4, proven that they were congruent, but in line 7, we just said that they were supplementary to each other. So if we go up here to the right angle theorem, it says we have to show they're supplementary, check, and we have to show they're congruent to each other, which is a check, which means we can say that angle ADB and ADC are right angles. And to be honest, so this is line 8. Instead of writing the whole theorem out, why bother if it has a name to it? So we're just going to call this the right angle theorem. So anytime a theorem has a name, use the name. It's just less writing. But if it helps you to write the actual theorem out, then that's definitely your choice. Then once we show that angle ADB and ADC are right angles by the right angle theorem, then we know that it's an altitude. So then we can say that AD is an altitude by definition of altitude. Because again, the definition of altitude just states that you have right angles. So that would be it. So that would be a nice 9-line proof. So that's a good one. All right, let's shift up so I can get the proof up here. Let's hope I can show it. Oh, good. All right, so we have example 2 here. So it says AB is congruent to AD and BC is congruent to CD. And we want to show that AC is the perpendicular bisector. So there's 2 words here, perpendicular and bisector. So step 1, we copy our given. Step 2, I'm going to say that AC is congruent to itself by the reflexive property. I forgot to add this congruent line in there, so these numbers are going to shift. So now the 2 triangles, top and bottom, are congruent by side, side, side. Then by CPCTC, I've got this little guy congruent to this little guy. And again, if you want, include everything else in CPCTC. It just might open the doors for more information to use. So now I've got to work my way inside of this figure. Currently, I'm working with the 2 bigger triangles. In order to show that AC is the perpendicular bisector of BD, I would have to show that BE is congruent to DE, and I have to show that angle AEB and AED are right angles. So those are the two things I have to do in order to be able to prove that. So now I'm going inside and I'm working with the smaller triangle. So now I'm going to say that AE is congruent to AE, which now lets me have these two little guys, AEB or ABE and ADE are congruent by SAS. So I've now proven two sets of triangles congruent. Within that, I want to then say that BE and DE are congruent. So step one, did it. So now I can say that AC bisects BD by definition of bisector. So I got part one. Also in my CPCTC from the previous thing, so you could actually put these together if you wanted. So together, if you want. Since they're the same reason and it's the same CPCTC from the triangles, you could have also said that AEB right here was congruent to AED. So let me actually number these. 6, 7, 8. We'll leave it separate for right now though. You can also write them separately. You never have to necessarily put them together. It just allows for less writing. And then, all right, so the only thing we have to add is if I'm now jumping to saying something is a right angle, you have to ask yourself, okay, is that actually correct? Have I included everything that I need? And the answer is no, because based on your actual right angle theorem, it states that not only do you have to have congruent angles, but they need to be supplementary to each other. So far we've only said that they're congruent. So now we have to do our supplementary line. So line 10 is going to say that angle BED is a straight angle. And we're going to assume that. And line 11 is going to say that BED is equal to 180. By definition, straight angle. So again, you're adding information in here, 10 and 11. At that point, we can then say for line 12 that those two angles are right angles. And again, you can either write it out or you can just write right angle theorem. I would again just write the right angle theorem. Then if we know that they're right angles, then I know that AC is perpendicular to BD by definition of perpendicular. And then for line 14, AC is the perpendicular bisector of BD by definition perpendicular bisector. So you always want to make sure you end again with the proof statement. So this is one of the longest ones we've done so far. But if you can see is most of the stuff besides one line